Hello, my name is Natalie Mahowald. I'm a professor of atmospheric science at Cornell University. Today, I'm going to talk about the atmospheric part of the microplastic cycle using a set of observations, an amazing set of observations that Janice Brainey and her co-authors published in Science last year, focused on the Western United States national parks and in rather mountainous regions. They detected quite a bit of microplastics in these regions that were coming from long-range transport, but not from local contamination. And so we put these into a model and deduced some of the different sources. We considered tires and braking as well as highway sources, an ocean source, just assuming microplastics at the surface of the ocean could be entrained into the atmosphere, agricultural dust and other dust downwind of population centers, as well as population centers. And so what we do, these are details here for the model connoisseurs, but what we do is we model a source and do the best we can with the temporal relationship of the source strength. And then we look at the transport to the deposition. So we look at the exact same time that the observations were made in the deposition. And so the model connects those two, assuming some source, and then we raise and lower the magnitude of the source everywhere based on that relationship. So we use an optimal estimation method, which also gives us information about the 95% confidence limits, for example. So what do we get? Well, we find in the Western US, most of the contribution comes from the road tire source, but the ocean source is not trivial. It could be important with a lot of uncertainty. And some of the other sources, ag source, dust source, and population sources. So these are roughly consistent with what little data there is, but really these all need to be better refined. Here's some comparisons, some illustrations of what we get. That here's the total microplastics from road sources, ocean sources. You can see the ocean sources are going to deposit right nearby for the most part and not make it to our observational sites, ag dust, population dust. If we extend this globally, we get something really interesting, which is that the road source is still there and it's consistent with the literature that's there, but the ocean source might be huge. It might be between 0 and 22 teragrams per year. About 8 is our best estimate, 8.6. So that's quite a bit of aerosol. So black carbon from anthropogenic sources is about 10. So that's a huge amount of microplastics into the atmosphere. And the other sources are also large. So we think about what's happening globally. There's a whole lot of source and sink over the ocean regions of the microplastics there. And then some of the ocean source gets onto land and some of the land sources then get out into the ocean. And you can see that segregated here in this plot. The ocean concentrations that we are assuming are really quite small for the size. We're between 400 and 300 microns in size that we're taking a look at. And so up to 50 grams per kilometer squared, whereas the observed plastics in the less than 5 millimeter size fraction is up to 50,000 grams per kilometer squared. So it could be larger potentially, but what we're deducing is a kind of a reasonable number of the pollution in this size. Overall, what we're getting in this study represents the first time that anyone has looked at the ocean source of dust in a model, tried to take a look at what could be happening, or I'm sorry, not of dust, of microplastics and all the other sources of microplastics. And we really come up with more questions than answers, but it looks like the resuspension of microplastics from the ocean into the atmosphere could really be an important process. Thank you.